Hello. Now in this video I'll be working the worksheet derivatives using product rule. I'll be working all 10 of the questions, and of course I'll backtrack and of course work some other videos on the previous worksheet, or do some other videos of the previous worksheet. Now you may hear some background noise and I apologize for that, but let's get right into it. Now under the product rule we'll be following a very simple rule, which is, just a moment, and it's acting up already. Just give me one moment to start this out. It's u dv dx plus v du dx. Now, this is always going to be the pattern that you need to remember, because of course this is the formula that you'll be making use of. Now, whenever you see a problem where you have the brackets multiplying, that's your indicator that you have to use the product rule. So you look here, you see all of them have two brackets. But if you say, for example, this one, this x, can also be considered to be in a bracket. And likewise here, this can be considered two separate brackets. So again, all product rules, we need to learn what the requirements look like so that you can know when you actually have to apply it. So the very first question goes x squared plus 1 and x plus 1 all squared. So you have u and you have v. So u is going to be equal to x squared plus 1 and v is going to be x plus 1 all squared. So my du dx is going to be 2x and my dv dx is going to be 2, right back the bracket, reduce the powers, this is 2 take 1, times derivative of the what is in the bracket, which is going to be just 1 because it's just x plus 1 there. So 2 times 1 is 2, and you have x plus 1 raised to the first power. So the reason why I do it this way is because I am able to see what u and v is, what du and dx also, du dx and dv dx also is. So I now put it all together. So looking at the formula, I probably should write it back once more. So I have u dv dx plus v du dx. So my u, let me just put dy dx, dy. Well, you should know this by now, everything is most likely going to be dy dx for derivatives. But anyways, moving on. U is x squared plus 1 and dv dx is 2 x plus 1 plus v now, which is up here, is x plus 1 all squared times du dx, which is going to be 2x. Now, at this point, I would go ahead and factorize. Other persons may, of course, do some additional work, but for me, I'll just go ahead and factorize. So we notice that we have x plus 1 here and x plus 1 all squared, which means we could take out one of the x plus 1 bracket. Now looking at what you have outside of the bracket, which is this 2 and this 2x. What you could factor out right away is 2. So I'm going to use a square bracket now. What I'm left with is x squared plus 1. I'm going to write it in brackets so you could keep up with me. So I just rolled back this here. Remember, the 2 is outside, this x plus 1 is outside, which means I'm now at the back here. Plus, remember, when I actually factor out 2, I'm left with x. So what I'm going to do now is I'm just going to put x there. And remember, I have to say I still have an x plus 1. That's left back there. So next line now, I have 2 bracket x plus 1, my square bracket. So this is not multiplying anything, it's just what's inside. So I have x squared plus 1 plus this x times x and the same x times 1. So this is going to be plus x squared plus x. And then now to finish this off, 2 open bracket x plus 1. I could use a normal bracket, but again, I just like my square brackets. So x squared and x squared is going to give me 2x squared plus, I'm going to put the x, plus 1. And with that there, that would be the first solution. Moving on to the next one. Alright, now this one here, you need to pay attention to something. I looked at the answer as well because I worked it completely out. But the answer didn't require for you to work it out. So I'm going to stop where they actually stopped. So y is equal to x plus 1 of the root of x plus 2. So this is my u and this is my v. So u is equal to x plus 1. So du dx is equal to 1. And v is equal to the root of x plus 2, which I can now write as x to the half plus 2. So dv over dx is equal to half x to the minus a half. And of course, the original constant is 0. So this here now, because I have a negative power, this is going to go at the bottom. So I'd have 1 over 2x to the half, which is actually 1 over 2 root 2. Now to understand, well, not root 2, root x. Now to understand this part here, I'm going to just do it once more for persons that still are a bit confused. The root of x is equal to x to the half. So look here now, x has a power of 1 and root actually has 2. So whatever is in the root symbol goes in the denominator, and whatever power is, it goes on top. So if I reverse that now, I have the 2 that's here, and I just write back my root of x. So that's what it is. So u dv over dx plus v du over dx. So my u is x, let me just write it again, dy upon dx is equal to x plus 1 of dv dx, which is 1 over 2 root x, plus v, which is the root of x plus 2, it's in bracket, which is going to be multiplying 1. So this is just itself. So going back to the front here now, this is equal to x plus 1 over 2 root 2, not root 2, 2 root x, plus the root of x plus 2. And that's how they actually have it. But this can be worked out more, as you see in later problems. They actually want you to work it out. Alright, so the next one, x squared. Alright, good. So the next question now. Just give me a moment. Again, I do apologize for the background noise. So y is equal to x squared plus x plus 1 of x minus 1. So this is u and this is v. So u is equal to x squared plus x plus 1 du over dx is equal to 2x plus 1. V is equal to x minus 1 dv upon dx is equal to 1. So what you'd also already notice that when you actually just have this normal that you're accustomed to, you could actually work these out pretty easily. So it's u dv over dx plus v du over dx. So is equal to u, which is x squared plus x plus 1 of dv dx, which is just 1, plus v, which is x minus 1 of du dx, which is 2x plus 1. So this is equal to x squared plus x plus 1, because of course when 1 multiplies it's going to be the same thing. And then you have plus, just showing the arrows of what I'm about to do. This is 2x squared plus x minus 2x minus 1. So in writing this out now, I'd have x squared plus x plus 1 plus 2x squared. This here is going to give me minus x, and I have minus 1. So this and this goes, this and this goes. So x squared plus 2x squared is going to give me 3x squared. Alright, next one is going to be x 7 15 cubed. So in this one, y is equal to x to the 7th plus 15 cubed. So like we said, u is equal to x, du upon dx is equal to 1, v is equal to x to the 7th plus 15 raised to the 3rd power. So dv upon dx is equal to 3, open bracket, x to the 7th plus 15 squared. And then of course what's in the bracket is going to be derived. We have 7x to the 6th. So this is now going to be equal to 3 times 7 to the 6 is going to be 21x to the 6th. Then we have x to the 7th plus 15 squared. So u dv dx plus v du dx dy upon dx is equal to u, which is x, dv dx, which is 21x to the 6th, which is multiplying x to the 7th plus 15 squared. So square bracket there, plus v, which is x to the 7th plus 15 raised to the 3rd power times 1. So this is just itself. Now, at this stage, what you should do is, and I'll say made as a practice, this and this multiply them out. So you have 21x to the 7th times x to the 7th plus 15 squared plus x to the 7th plus 15, and this is times 1, so this is just going to be the cube. Now you take out what you can, so this is x to the 7th to the 15, also x to the 7th to the 15, this one is squared, which is lower, so x to the 7th plus 15 squared, and then in my next bracket now I'll have 21x to the 7th plus this one time x to the 7th plus 15. And now working this out, you'd have x to the 7th plus 15 squared of 22x to the 7th plus 15. Remember here just 21 plus 1, 22. Now again, once you see, you don't have to deal with anything too fancy. These questions are relatively easy. It just comes down to the factorization component. So this is going to be another easy one to actually work out. So here I have x squared x plus 7 raised to the 3rd power, x plus 7 raised to the third power. So this is u and this is v. So u is equal to x squared, du upon dx is equal to 2x. V is equal to x plus 7 raised to the third power. dv upon dx is equal to 3 x plus 7 squared times 1. So 3 into x plus 7 squared. So again, u dv upon dx plus v du upon dx. Now this is something I should point out. I'm sticking to what Sir said to actually focus on. That's why I'm keep writing this, but of course you need to remember how you have f of x and f prime as well. You need to pay attention to that because I do remember seeing questions like that appearing in the test that we just had the day before. So dy upon dx is equal to u, and u is x squared. dv dx is 3 x plus 7 squared, which is now added on to v, which is x plus 7 cubed, times du dx, which is 2x. So like I said before, get this out of the way. So you'd have 3x squared of x plus 7 squared plus, I'll put it 2x in front, and then we have x plus 7 cubed. Now something to take note of, as per normal, this is always, or one of them is always going to be at least one less, and that's what you're actually going to factor out. So I always say factor out the bracket, knowing that you'll just have one left somewhere there. Now you look for what else you can actually take out. Now in this case we have 3x squared and 2x. So the numbers can't really work out to be factorized, but you can take out an x. So what you're now left with is 3x. Remember, this is now here, so 3x alone came out from that. Plus, remember you took away, okay, give me a sec here. Okay, you took away the x, so you're left now with 2, and then you have x plus 7. Yeah, sometimes I just got to really slow down and watch this thing. So remember, this x is in front here, so you have 2 with the bracket. So you'd have x into x plus 7 squared of 3x plus 2x plus 14, and so this is equal to x plus 7 squared. 3x plus 2x is 5x plus 14. And that's that. Alright. So the next one now, the x to 7. Yeah, I think this is where things start to get complicated. When I say complicated, unlike the question I said earlier on where I said I worked it out, but the answer sheet didn't have it worked out, this is one where they actually showed you everything worked out, so I'll show you that as well. Also, something that most mathematicians do when we normally solve, but if you're told to simplify everything, then you need to ensure that the step that I show you after I say what mathematicians do, you actually complete it. So x to the 7th, 4x squared plus 7. Alright, so let's go. So y is equal to x to the 7th square root of 4x squared plus 7. So this is u and this is v. So u is equal to x to the 7th, du upon dx is equal to 7x to the 6th. Now v, which is given as the root of 4x squared plus 7, you already know right away that we need to rewrite this, so this is going to be to the root of 4x squared plus 7 raised, what am I doing? This is not it. V is equal to 4x squared plus 7 raised to the half. So dv dx is equal to a half of 4x squared plus 7. So a half minus 1 times 2 times 4, which is going to give me 8x. So this is 2, giving me here now 4. So I'm just going to direct my answer here just on the dv dx. So dv dx is equal to 4x being divided by the root of 4x squared plus 7. I don't think I need to explain that part here, because remember the power of course goes down, and since 4x is going to be in the numerator area, it just goes above. So the u dv dx plus the v du dx. So my u is, just give a moment, kind of system froze. So dy upon dx, my u is x to the 7th, my dv dx is 4x over the root of 4x squared plus 7, right, plus sine v, 4x squared plus root of 4x squared plus 7, root of 4x squared plus 7, and the u dx would be 7x to the 6th. Now, this is where things get very interesting. So of course I'm going to multiply out here, so I'm going to have 4x to the 8th being divided by the root of 4x squared plus 7, which is added to 7x to the 6th of, let me see here, the root of 4x squared plus 7. I have it in brackets for my own personal reasons when I explain, just a moment from now. Now, unlike before, where I didn't work it out, this is going to be fractional. So you just put divided by 1. Now the LCM is going to be the root of 4x squared plus 7. Let's give me a moment. 4x squared plus 7, which is, alright, just for the sake of simplicity, just put 1. Because you'll need to understand why I do this later on. So when you actually have this done, you're having times 1. So you're going to be left with the 4x to the 8th. And here now, what you're going to have is 4x squared plus 7 rooted. Now, remembering your surds, when they're alike and they multiply out, we're just going to have whatever is under the root symbol. So this is going to be 7x to the 6th multiplying 4x squared plus 7. So 7 4s is 28. You have your x, 6 plus 2 is 8, plus 7 7s is 49, and then you have x to the 6th. So this is now equal to the 4x to the 8 and 28. X to the 8 is going to give you 32 x to the 8 plus 49 x to the 6th being divided by the root of 4x squared plus 7. I'm not going to write back 1 because it's not necessary, but that's your, wait, wrong, it's just to the 8 to the 8. Yeah, and that there would be the answer. Let me just zoom back out. Oh, I think look when I, oh, like that, U. Alright, next question. Alright, What's the next one? X is 7, so I have to do the root of x. X squared plus 4. So y is equal to the root of x squared plus 4. So u is equal to the root of x. So u is equal to x to the half. So du upon dx is equal to a half of x to the minus a half, which is equal to 1 over 2 root x. Again, I think you should at least know that pattern by now. And v is equal to x squared plus 4. So dv upon dx is equal to 2x. So u dv upon dx plus v du upon dx dy dx. So u is root of x dv dx 2x plus v, which is x squared plus 4 times 1 over 2 root x. So I'm going to come all the way down here now. So this is actually going to give me 2x root x plus x squared plus 4 divided by 2 root x. Now, as before, it's going to be fractional from this point, so this is divided by 1. So 2 root x. So immediately, alright, so let me just don't do it like that. Let me work out this part here for you so you see what's about to happen. So if you're going to have 2x root x, which is now going to be multiplied by 2 root x, you're going to have 2x and times 2 is going to give you 4x. Multiplying the root times the root is going to give you just x, which is under. So you have 4x squared. So here's 4x squared. And here now, you're going to just write back what is above here, which is x squared plus 4. So 4x squared plus x squared plus 4 is going to give me 5x squared plus 4 being divided by 2 root x. I believe the answer is something different here. Yeah, this is what they have. So I'm not certain if what I did is correct. So if anyone actually worked and got that, just share it in the Google Classroom, or even comment underneath the video. So the next one is which one? What is the next one? What is the next one? X squared plus 1? X squared minus 1. Alright. So y is equal to the root of x squared plus 1 times x squared minus 1, which is also rooted. I believe this is a question that I'll need to highlight something on when it comes to solving. But if you're just having to do what this is required to do, you'll need to ensure you pay attention to the last bit I will show you. Actually, I'm not at dy dx's yet. I'm at u and v. So get rid of this. So jumping in, u is equal to the root of x squared plus 1. So u is equal to x squared plus 1 raised to the power of a half. So du upon dx is equal to a half of x squared plus 1 raised to the minus a half times 2x. So this is going to go. So we are left with x being divided by the root of x squared plus 1. So that's my du dx. Now v is equal to x squared minus 1, which is also rooted. So v is equal to x squared minus 1 raised to a half So dv upon dx is equal to 1 upon 2 of x squared minus 1 raised to minus a half times 2x. So this is equal to x being divided, x above x squared minus 1. So I have my u, I have my du dx, I have my v du dx. So just a moment, pen is frozen right now. Alright, great. So u dv dx plus v du dx. So this is actually one of those questions wherein I need to really slow my roll a bit. So dy upon dx, so u is the root of x squared plus 1, dv dx is x divided by the root of x squared minus 1, which is now added to v, which is the root of x squared minus 1 being the, no, shouldn't put this division sign as yet. Should not put division sign as yet. Which is then multiplied by the u dx, which is x over the root of x squared plus 1. So what this actually now gives you is put x in front, root symbol x squared plus 1, which is all being divided by the root of x squared minus 1, which is now added on to x root of x squared minus 1 divided by the root of x squared plus 1. Because I don't know how much I'll be writing now. Alright, so next step, root of x squared minus 1 and also the root of x squared plus 1. Now, at this step, you need to also just remember that whatever is in the denominator is going to look at what's in the LCM, it's going to cancel what's in the LCM, and it's going to leave you with the other side. So this is going to be multiplied by the root of x squared plus 1, and this side here is going to be multiplied by the root of x squared minus 1. So you should already recognize that the root symbols are going to cancel, giving you just what's under the root symbol. So I'm going to have x of x squared plus 1 multiplied by x of x squared minus 1. So this is going to give me x cubed plus x cubed minus x, all being divided by the root of x squared minus 1 and the root of x squared plus 1. Now, most mathematicians that I know normally would stop at this line, but I'll show you why you shouldn't right after this. So you're having 2x cubed because these two go. Then you have the root of, no, I shouldn't do this as yet. Should not do this as yet. I need to explain that part. The root of x squared minus 1 and the root of x squared plus 1. Now, this is a step that most persons would just stop at because you would then be plugging in values for x and you would solve. But if you're told to simplify, which is what this worksheet actually requires, even though it doesn't all the time, you need to make this make sense? Well, so I'm going to word this separately now for you. So the root of x squared minus 1 times the root of x squared plus 1. So what you're actually doing right now is you're multiplying two similar roots, not based on what they have underneath, but based on what's, let's say, here. So what you're going to do now is you're going to have, let's say, big root of x squared minus 1 and x squared plus 1. So this is going to be equal to the root of x to the fourth plus x squared minus x squared minus 1. So these two go, which is going to give you the root of x to the fourth minus 1. So your actual answer for this question, dy upon dx, is equal to 2x cubed over x to the fourth minus 1, which is all rooted. So again, if you're actually going to just solve, most persons would just stop here, plug in for whichever value they have to plug in for, and then work from there. But if you're going to simplify, then this step is actually needed. Alright, so what is the next one? 2x plus 1, 2x minus 1. Alright. So y is equal to 2x plus 1, 2x minus 1 raised to the 4th. So again, this is very simple to actually work out. U is equal to 2x plus 1, du upon dx is equal to 2. So v is equal to 2x minus 1 raised to the 4th. dv upon dx is equal to 4 of 2x minus 1 raised to the 3rd times 2, which is going to be 8 of 2x minus 1 raised to the 3rd power. So u dv upon dx plus v du upon dx, dy upon dx is equal to u, which is 2x plus 1 dv dx, which is 8 of 2x minus 1 to the 3rd power. Positioning is off. Just allow me a moment. Let me just realign myself. Good. So this is plus v, which is 2x minus 1 to the 4th, and dv dx, which is just 2. Okay, so like I showed you in earlier problems, get rid of that. So 8 2 is 16x plus 8 of 2x minus 1 cubed plus 2x minus 1 to the 4th. I'm just putting the 2 in front. So as per normal, you take out one of the brackets with the lowest power. Boom. Now, looking here now, this is already, so let me just get this out to review because it's now at the bottom here. So this is at the back. We have 2, 8, and 16. 2 can divide all of them, so we have 2 in front here. Leaving me with 8x plus 4 plus 2x minus 1. So this is going to give me 2 of 2x minus 1 to the 3rd power. In my bracket here, 8x plus 2x is 10x. 4 take 1 is going to give me 3. And that's it. I think it's one more question. Yeah. Alright, this one is actually a whole lot easier than it actually panned out to be. It looks like a headache, but it's actually not. So y is equal to the root of x minus 1 times the root of x plus 1. So u is equal to, I'm just going to write it how it's supposed to look, and v is equal to x to the half plus 1. So du upon dx is equal to, we already did this before, so it's 1 over 2 root x, and likewise on this side here, dv upon dx is also equal to 1 over 2 root x. So that's the beauty of it. Once you see you actually work the problems enough, you just know what happens when given certain situations. So u dv upon dx plus v du upon dx dy upon dx is equal to u, the root of x minus 1, times dv dx is 1 over 2 root x plus v root x plus 1, and then I have 1 over 2 root x. So what this now gives me is the root of x minus 1 divided by 2 root x plus the root of x plus 1 divided by 2 root x. Now the roots are similar, but for the sake of problem solving, let's just write it out. So what I have now is the root of x minus 1 plus the root of x plus 1. The ones go, which is going to give me 2 root x, which is being divided by 2 root x, which is going to give me 1 over 1, which is going to give me 1. Okay, and with that here, I would have concluded the working of the derivatives using product rule worksheet. I hope this video finds you well, and do enjoy the rest of your day.